In today's lesson, we're going to look at infinite geometric series. And as usual, just before we get started, I just want to remind you on how to do mathematics. Now make sure that you understand each step in the examples. You will not learn how to do maths by reading it or watching someone else explain it to you. Understanding the steps does not necessarily mean you can do it on your own yet. Therefore, to get the most out of this lesson, make sure to pause and do the questions before watching the answers. You improve your skills only through practice, but more specifically marking your practice sums and learning from your mistakes. Right, so an overview of what we'll be doing is, first of all, we'll look at the formula, and then we'll look at calculating the sum to infinity using our formula, and then finally we'll look at converging and diverging series. Now, when I have a geometric series that has a ratio, a constant ratio, which falls between the values -1 and 1, what happens then is I am then allowed to, or I can then calculate the sum to infinity of that series. And the formula for the sum to infinity is as follows. We've got sum to infinity is equal to a over 1 minus r. And then the a value, as usual, is just simply our first term. And the r value, as we know, is the constant ratio. Right, so now let's look at how to use our formula. Now for the first example, example 31, determine the sum to infinity of the series 75 plus 50 plus 100 over 3. Now, first of all, if I see the word sum to infinity, I can immediately also know that it will be a geometric series, since we only calculate the sum to infinity with geometric series. So first of all, I write down my formula as sum to infinity is equal to a over 1 minus r. And then I can see that I need the a value and the r value. So that's not too much. The a value is very easy. It's just your first term, which is 75. And then the r value also, we know, is just your term 2 over term 1 or term 3 over term 2. So then calculating that, we have 50 divided by 75, and that gives us 2 over 3. We can also double check, although when they tell you to determine the sum to infinity, you can actually almost know that there is going to be a common ratio, but you can double check that by just saying, okay, what is term 3 over term 2 then? So you have 100 over 3 divided by 50, and that's equal to also 2 over 3. Okay, so our common ratio is 2 over 3, and then we simply substitute these values into our formula. So a is then 75 over 1 minus 2/3, and then we just type it in. So that's 225. Right, so for question 31.1, determine the sum to infinity of the series 16 plus 4 plus 1. So first of all, they're asking me for the sum to infinity, so I write down my formula. Sum to infinity is a over 1 minus r. My a value is equal to 16, and my r value is just 1 divided by 4, 4 divided by 16, and both of those just simplify to 1 over 4. So I substitute in my values as 16 over 1 minus 1/4, and then I can type it in. So that's 64 over 3. Okay, so question 31.2, determine the sum to infinity of the series 130 minus 52 plus 104 over 5. Immediately I see my terms are a positive, negative, positive, so I know my ratio is going to be a negative value. So first of all, let's write down our formula. Sum to infinity is equal to a over 1 minus r, and then our a value is 130, and our common ratio is then going to be term 2 over term 1. So we can say negative 52 over 130, and that would give us negative 2 over 5. Okay, now all that's left is substituting. So 130 over 1 minus negative 2 over 5. And then we work that out. And I can type it in just like this, but I know that a negative and negative just gives me a positive, so I'm just going to type 1 plus 2 over 5. And that gives me 650 over 7. Then question 31.3, determine the sum to infinity of the series 0,81 plus 0,27 plus 0,09. Okay, so we start off by, we have to calculate the sum to infinity, so we write down our formula. Sum to infinity is a over 1 minus r, and we have a value, in this case, of 0,81, and a r value of 0,27, so 0.27 divided by 0,81, and that gives us a third. Okay, substituting in 0,81 over 1 minus 1 over 3, and then calculating 0,81 over 1 minus 1 over 3. And that gives us 243 over 200. Okay, so that was easy enough. Now let's see what it means when something converges or diverges. Now, first of all, we had this restriction, and it says that if your constant ratio is greater than -1 and less than 1, the sum of the series will converge. Now, what it means to converge is if this common ratio is a fraction, then the number that you keep adding becomes smaller and smaller and smaller. So that means if you're going to add up until infinity, that number, it's going to eventually become so small that it's practically equal to 0. That's what it means when you say a number tends to 0. It's so small that it becomes almost 0. So when you are going to start keep on adding numbers that's practically 0, you're going to the series will converge to, the sum of the series will converge to a specific value. And that is why we can actually determine the sum of the infinite geometric series when the common ratio falls between these two values. But what happens if the R value, or your common ratio, falls outside of this range? Then we have something, for example, 2, and let's say we're adding a series that has 2 plus 4 plus 8 plus 16. See, the values that you're adding is becoming bigger and bigger and bigger. So you're just gonna, the answer is just gonna shot up into infinity. Like it's not gonna converge to a specific value. It's just going to go up until infinity. So then that means that your series, then if you work out the sum, it diverges, and that is why we say that the R value needs to be between -1 and 1. Okay, so for example 32, the type of questions that we can expect when it comes to converging and diverging are as follows. It says, consider the geometric series P plus P times yp plus 1 plus P times yp plus 1 squared. For what values of P will the series converge? Now, the moment you see this word converge, immediately write down the restriction as -1 is less than R is -1. Because now what happens, this is what you use to test if the series converges. And then it says in terms of P, so if I look at this series, what is the common ratio in terms of P? I can see that I have to multiply with P plus 1 to get the next term the whole time. If it's not that obvious for you, or if it isn't that obvious in general, what we do is remember that your common ratio is just term 2 over term 1. So we're basically just going to write it just as it is, and then we just simplify this. The p's cancel, and then we're just left with p plus 1. Okay, so you can either determine it like if you see it immediately, or you can basically just go with the normal method of saying term 2 over term 1 or term 3 over term 2. Okay, so now that we have that, we just simply substitute our R value in terms of P, or the variable, into our relationship or restriction. So -1 is less than P plus 1 is less than 1. So, and now you just have an inequality to solve. And remember, with these type of inequalities, we have two inequalities in this expression. We take the 1 to both sides. Okay, and if you have a coefficient over here, you divide all three parts of this inequality with whatever the coefficient is. Okay, so if I take the 1 over, it becomes -1 is less than P is less than 1 minus 1. And then the final answer is simply going to be -2 is less than P is less than 0. And that is it. Now for question 32.1, for which values of x will the geometric series converge? Now first of all, remember we see the word converge, so we write down what is our restrictions for a series to converge. It's -1 is less than R is less than 1. Then you have to determine what is your R value. And my R value in terms of x, to get the next term, I have to multiply it with 2x plus 1. And then I just substitute my R value into my restriction. -1 is less than 2x plus 1 is less than 1. And then I solve. So first of all, the 1 goes over. So if it goes over, this plus 1 becomes a -1. On this side, we have -1 minus 1. So that gives me -2 is less than. And then 2x is less than. And if this 1 goes over, it becomes -1 and it becomes 0. And then I have to get rid of this 2. So I divide all three parts with 2. And that leaves me with -1 is less than. Those two also cancel. X is less than 0. And that is my final answer. Consider the geometric series k squared minus k squared times by k minus 2 plus k squared times by k minus 2 squared. For what values of k will the series converge? Now, be careful with the signs as well in this one, because there's actually a lot going on. You could miss this. This one is a positive, that's a negative, that's a positive. So this is actually your R value in this case will actually be a negative value. We can see k squared appears in all the terms, so that's constant. But for each consecutive term, there's been a k minus 2 multiplied. So first of all, my series converge for which values? So I've got -1 is less than R is less than 1. And then my R value is simply going to be, so negative times by -k minus 2 is then the constant ratio. So I substitute that into the relationship. Is less than 1. Okay. Now, another thing you need to remember with inequalities, whenever you divide by a negative number, because the first thing we want to get rid of here is this negative. So whenever you divide by a negative number, your inequalities change its sign. So if I go everyone, I'm going to divide everyone with -1. Then this becomes a positive value, so that's just 1. But this sign becomes greater than. This negatives cancel, so you're just left with k minus 2. And then that sign becomes greater than, and that becomes -1. All right, and then we just need to get rid of this -2, so I take it over to this side, it becomes plus. Then it's 1 plus 2 is 3, is greater than k, is greater than, and if I take it over to this side, it's -1 plus 2, which is just 1. All right, now I could leave my answer like this, but to be 100% correct, we can just rewrite it rather than 3 is greater than k is greater than 1. We rather write it as 1 is less than k is less than 3. Right, so for question 32.3, for which values of x will the geometric series 2x plus 4x squared plus 8x cubed converge? Alright, so converge means that the R value needs to fall between -1 and 1. And what is my R value? My R value is every time I multiply with 2x. So this is then just 2x. And then we substitute it in. So -1 is less than 2x is less than 1. And divide everything with 2. Alright, so negative a half is less than x is less than a half, and that's it. Alright, so this is then the last section. It was nice and short, and then we are finished.